until a visible clot is formed. As the clot forms, the mixture will gelatinize and may turn cloudy. As long as the clot is not formed, the plasma is clear and flows along the sides of the test tubes. As the clotting starts, the plasma turns turbid and the movement stops. This is why we employ the tilt tube method, as the tilting enables us to see the flow along the sides. 8. Stop the stopwatch immediately when the clot begins to form and record the time in seconds. Carry out one significant figure past the decimal point. For example, if your result is 12.23 seconds, report as 12.2 seconds. 9. In our example, the controlled result is 15 seconds. 10. Similarly, run the test sample. Always run each sample in duplicate whenever you run samples manually to rule out errors. For all duplicate runs, always calculate the percentage difference between the two readings. A percentage difference of more than 10 is unacceptable and that sample should be retested. The test results for the duplicate sample run are 16 seconds and 17 seconds. The average of the two readings give the final value. The normal range for PT is 10 to 13 seconds. It has to be established by each lab by MNPT. Document the results immediately. The documentation log should contain the following information: PT methodology, reagent name and lot number, ISI, MNPT and lab range values, date, name and ID of the patient, patient readings, mean and INR value. 11.
If the result is more than 30 seconds and INR is more than 2, inform it, as this could be a critical value. For several therapeutic reasons of anticoagulation, INR is maintained at a high level. For example, normal INR is less than 1.2.
Expected INR in oral anticoagulant therapy for prophylaxis for recurrent DVT is 2 to 3. Expected INR in oral anticoagulant therapy for recurrent MI is between 2.5 to 3.5. Expected INR in anticoagulant therapy for heart valve replacement is user-specific. Thus, relevant patient history is very important before reporting the PT. APT, activated partial thromboplastin time, is used to evaluate coagulation abnormalities in the intrinsic pathway and also to detect severe functional deficiencies in factors 2, 5, 10 or fibrinogen. Specimen collection. It is similar to specimen collection for PT. The materials required: 1. 12 by 75 test tube. 2. Pipettes 100 microliters. 3. Pipette tips. 4. Calcium chloride reagent 0.025 m. 5. Partial thromboplastin consists of phospholipids and a contact activator. 6. Water bath, incubator or heat block at 37 degrees Celsius. 7. Test tube rack. 8. Wipes or gauze. 9. Stopwatch. 10. Controls. In our demonstration, the range of controls is defined between 35 to 53 seconds. 11. Patient's citrated plasma specimen. Once the reagents and controls are reconstituted, write the date, time, the expiration date, time, and technology's initial on the bottle. Procedure. 1. Pre-warm a sufficient quantity of calcium chloride reagent to 37 degrees Celsius for the number of tests to be performed. 2. Pipette 100 microliters or 0.1 ml of control into a labeled test tube. 3. Into the test tube, add 100 microliters or 0.1 ml of pre-warmed partial thromboplastin reagent. 4. Incubate the control and the partial thromboplastin mixture at 37 degrees Celsius for 3 minutes. 5. Add 100 microliters or 0.1 ml of calcium chloride into the control and the partial thromboplastin mixture and start the stopwatch immediately. 6. Mix the tube once immediately after adding the calcium reagent. Allow the tube to remain in the water bath approximately 20 seconds, mixing occasionally. 7. Start observation after 20 seconds. Deftly removing and re-immersing the tube from the water bath. Wipe off the outside of the tube. Gently tilt the tube back and forth until a visible clot forms. 8. Stop the stopwatch immediately and record the time in seconds. Carry out one significant figure past the decimal point. For example, if your result is 30.31, report as 30.3 seconds. In our observation, the time recorded is 40 seconds. 9. Similarly, run the test sample in duplicate to rule out errors. The readings are 39 seconds for tube 1 and 41 seconds for tube 2. The average of the two gives us the final value of APTT. The normal range for APTT in our demonstration is 22 to 35 seconds according to the kit insert. However, all labs should establish their own normal ranges by analyzing 20 normal samples and finding the mean. Using a coagulation analyzer for PT and APTT. Coagulation analyzers are either fully automated systems or semi-automated systems. In semi-automated system, most of the functions are still manual. For example, pre-warming, pipetting, etc. All what the equipment does is incubation and clot detection. Also, coagulation analyzers are of multiple methodologies. We are going to show a semi-automatic photo-optical equipment where the clot formation is detected using a laser LED optic.
The following points are crucial to coagulation analyzers: the calibration curve, temperature setting mechanisms, optics and mechanics, and the timer.
These should be understood for their functions and checked as per the manufacturer's instructions. Appropriate preventive maintenance should be undertaken to keep these measurement mechanisms at the optimum. A manual method is more under control than a semi-automated technique unless you can check out the above. Blindly following procedural steps may result in wrong results if the temperature, optics, and timer are inadequately maintained. In this equipment, calibration is done for a normal of 30 seconds for APTT and calibration for PT is done as a default for ISI equal to 1.10. Temperature adjustment is done for 37 degrees Celsius. Optics are also adjusted to a high and low range with limits for amplification. Whenever the PT lot changes, the MNPT and the ISI value changes and the equipment settings should be readjusted. Procedural steps for this equipment is as follows. Warm up the instrument. It takes about 5 minutes for the instrument to equilibrate to 37 degrees Celsius. Different equipment will have their own specific instructions for use. Those have to be strictly followed. The test procedure for PT: run one test sample in duplication and calculate the percentage difference between the two readings. A percentage difference of more than 10 is unacceptable and that sample should be retested. Some machines can be programmed for duplicate testing. If your machine does not have this feature, run the same sample twice. Clotting method. Pipette 25 microliter plasma to cuvette. Pre-warm the plasma for 60 seconds. Press the timer 1 key to start the stopwatch 1. Transfer the cuvette to measuring position. Add 50 microliters pre-warmed and stirred thromboplastin reagent. The test will start automatically on addition of the start reagent. The test is displayed in seconds. Press the corresponding unit key for conversion of the results. The PT and INR results in our demonstration are 20.9 seconds and 1.70 respectively for tube 1 and 20.7 seconds and 1.68 respectively for tube 2. Test procedure for APTT. 1. Pipette 25 microliters plasma into the cuvette. 2. Add 25 microliters APTT to plasma. 3. Incubate exactly for 5 minutes or 3 minutes for ellagic acid-based APTT reagents. 4. Transfer the cuvette to measuring position. 5. Activate the optic. Press key optic. 6. Add 25 microliters pre-warmed calcium chloride and simultaneously start the optic. 7. The instrument will read for a maximum of 300 seconds. 8. The result is displayed in seconds. Sources of error in coagulation tests. 1. Associated with specimen. Inappropriate ratio of anticoagulant to blood. Clotted, hemolyzed or lipemic samples. Poor centrifugation resulting in high platelets greater than 10,000 platelets per microliter. Delay in testing or processing. Inappropriate storage.
Associated with reagents: incorrect preparation of reagents, failure to properly store reagents, use of reagents beyond reconstituted stability time or expiration date, contaminated reagents. associated with procedure. Incorrect temperature. Incorrect incubation times. Increased incubation time is equal to decreased coagulation time. More than 5 minutes heating will result in the loss of heat labile factor 5. Incorrect volumes of samples, reagents, or both.